Welcome back. My name is Elias Sinkala, aka Professor Elias. So let's try to explore further mathematics 110. Yes, this is mathematical induction. Please don't forget to subscribe, comment, like, and also share. And also tap the notification button there for more information. Okay, so my main question here is about mathematical induction. So if you see question 6, that is question 6, n open bracket n plus 1, n plus 2, n plus 3 is indivisible by 24. So in this case, before going further, first of all, there's some of the things that you have to burn with it in your mind when dealing with mathematical induction. So mathematical induction consists of three steps. Step 1, you have to prove, of which also you have to conclude. Step 2, it's the appearance of step 2, it's the purpose of step 3, of which there is no conclusion in step 2, but the conclusion is in step 3. Yes. So there are some of the rules, and also we do not go direct in terms of our questions when it comes to mathematical induction, but we follow orderly, then no need of calculating with the concluding numbers. So what I mean, you're going to understand further in my explanation. So let's try to go ahead. Yes, this is to explore within 5 minutes so that we can create more room of understanding. Yes. So according to our question, so this is our question. N plus 1, n plus 2, n plus 3 is divisible by 24. So like what I said, mathematical induction consists of 3 steps. So in step number 1, always you have to rate n is equal to 1, of which in this case, whatever there is n, you have to put 1. If there is no any condition attached to it, if you see very much proper, no any condition attached to it, so you have to rate n is equal to what? 1. That's an assumption that you have to develop. Then we say, where I get this actual equation, n plus 2, n plus 3, and whatever, if I replace whatever I'm going to find should be dividable or divisible by what? 24. So then I say, whatever there is n, I put 1. Whatever there is n, I put 1. Then 1, then I can follow now the board must now deal with those that are in brackets, I mean parentheses. 1 plus 1, that is 2. 1 plus 2, that is 3. 1 plus 3, that is 4. Remember, I'm going to find here it should be divisible by 24. Then 1, 2 times 2, 2 times 3, that is 6. Then here 4. Then this times this, everything here, that is 24. If you see very much proper, this 24 or this 24 or this 24 can divide by what? That 24, of which that is 1. Of which that is true, therefore can conclude to say, therefore, it is true, n is equal to 1. We'll go in step 2. So 2 more steps to conclude. So step 2, always have to say rate n is equal to k, of which get the actual equation, n plus 1, n plus 2, n plus 3. Whatever there is n, I put k. Whatever there is n, I put k, according to the assumption that I've already developed. K plus 2, k plus 3. Then, I go ahead. In this case, this is the end of step 2. And I have to put a star here. That symbolizes to say there is an extent of which in step 2 where I'm going to get back. Like what I said, step 2 is the purpose of step 3. And we cannot conclude here. We're going to conclude in step 3. Hence, the appearance of step 2, it's the purpose of what step 3. So I say step 3, right? N is equal to k plus 1. Then I say, so I'm going to start where I ended in step 3, in step 2, then I continue in step 3. So I say k plus 1, k plus 2, k plus 3, plus, allow me to now to write the final, let me say the actual equation, n plus 1, n plus 2, n plus 3. Then I say k, open k plus 1, the same thing, k plus 2, like what I said, do not calculate here one to reach at the concluding number, no? Then, now whatever is n, I'll be put to what? K plus 1. K plus 1. Now that's to make 2, because 1 plus 1 to be 2. Here to be k plus what? 3. Here to be k plus what? 4. Right? Then, note that the operating difference here is what? It is positive here, which is plus. Like that's the one that is separating from the numbers that are on right and left. So which those numbers that are on right and left should be equal. Now it's you see very much properly, k plus 1, k plus 2, k plus 3, k plus 3. They're equal to k plus 1, k plus 2, k plus 3, but k plus 4 and this k, they're totally different. Hence, you can remove them, you can expand this one out of the brackets, right? Of which, at the end of the day, since you have already k, you have already have k here, it remain one and the same. Of which, for here, we can diverge it and come here so that it can come here. At the end of the day, if you add them to be k plus 1, of which to symbolize one and the same. What I mean is this: we're going to say k plus 1, k plus 2, k plus 3, plus this 4 has to come here. This k is same applies with here. K plus 4, following, for instance, if we follow quadratic equation, at the end of the day, there's some where we try to group those that are outside. And at the end of the day, we're going to find what? We're going to have this kind of numbers. So we're going to, then we're going to remain with what? K plus 1, then k plus what? 2, k plus what? 3. Then this is the end of step 3. Then you can even conclude to say, therefore, it is true n is equal to k plus 1, hence it is true n is a member of what? Natural numbers. Thank you very much. Don't forget to subscribe, comment, like, and also share. Thank you. See you in the next video. Thank you.